So in the last video, we used trigonometry to identify a missing side of a right triangle. The triangle was provided to us. There wasn't any context. This type of problem I would kind of consider the middle difficulty type of situation to encounter when you're first starting to apply sine, cosine, and tangent within solving situations. And the reason why I would identify this as kind of the middle scenario is because although this is a story problem, there's something described here. The picture is provided for us. There's nothing that we have to label on the picture. There's nothing that we have to take out of the problem and figure out how it fits. Everything's labeled on the picture. So although there is a situation, we've got this tent and we have a rope connecting from the top of the tent to this stake that's placed into the ground. We are told how high the tent is. The tent is 40 feet tall. We're also told that the angle the rope makes with the ground is 52 degrees in 15 minutes. What you'll notice I did right here is I turned that into the appropriate decimal version. So I took 15 and divided by 60 to turn that number of minutes into a decimal, and I got 0.25 as the appropriate decimal. If you're wondering where that came from, just look for another video about converting from degrees, minutes, seconds to degrees or vice versa, and that should make some sense to you. But we have the angle here. What we're asked is we're asked two things. How long is the rope? So what is the length of R? And then what is the distance between the stake and the bottom of the tent? So what is D? So we have two different pieces here. Starting with part A, what we're going to need to do is we're going to need to figure out how this angle that we know, the side that we know, and the side that we want in part A is for the length of the rope. So we want to know what R is. We don't need to look at the right angle here other than to give us the green light, right? If it is a right triangle, which this clearly is, we have the green light to use sine, cosine, and tangent, to use right triangle trigonometry. So we have the opportunity to proceed through this problem using sine, cosine, and tangent. But what we need to do for part A is we need to identify which portion of SOHCAHTOA is going to be the portion that's going to be the appropriate one to use to identify the length of the rope. So how is the side that we know related to the angle that we know that is not the right angle? So is it the A, the O, or the H? The opposite leg, the adjacent leg, or the hypotenuse of the triangle? It should be pretty obvious this is not the hypotenuse, right? Across from the right angle is R. So R is the hypotenuse. But the side that we know, it's not along the angle that we know. It's not next to the angle that we know. It's on the other side of the triangle from the angle that we know. This is the opposite leg relative to that 52.25 degree angle. So if this is opposite, and we said a few seconds ago that R is the hypotenuse, the side that we want to determine in part A is the hypotenuse. So we have opposite and hypotenuse. Which of the syllables from SOHCAHTOA involve the O and the H? And that would be that first syllable. So what we're going to do for part A is we're going to use the sine function. Sine is equal to the opposite leg divided by the hypotenuse of the triangle. So ignore this R that you see written here initially. We'll talk about where that comes from in just a minute. So what I did is I did sine ratio of the angle that we were dealing with. So the input to these trig ratios is always going to be an angle measure. So sine of the angle that we were just working with equals the opposite leg, which measured 40 feet, divided by the hypotenuse of the triangle, which was R units. That's what we're looking for within part A here. I need to solve for R. So the reason why you see a times R over on this side, if I'm trying to solve for R and determine the value of R, I need to make sure R is not in the denominator of a fraction. So what I did is I got R out of the denominator of the fraction by multiplying both sides by R. When I multiply the right-hand side, when I multiply this fraction by R, an R in the numerator multiplied together with something that involves an R in the denominator is going to allow us to just multiply those R's out into a 1, and then 40 times 1 is just 40. You might also say that these cancel with each other. But on the right-hand side of the equation, we're just going to be left with a 40. But I can't just multiply the right-hand side of the equation by R. I also have to multiply the left-hand side of the equation by R. So the times R that you see over here is actually from keeping the equation balanced. If I want to multiply the right-hand side of the equation by R, I also have to multiply the left-hand side of the equation by R. Now to solve this equation for r, I'm going to have to undo this multiplication between the r and the sine of 52.25 degrees. From time to time, I hear people say, well, I'm going to divide by sine, or maybe I'm going to divide by 52.25 degrees. You're actually going to have to keep this entire portion of the equation together. Just sine makes no sense without something inside of it. And I can't take the 52.25 out of the sine ratio because then I've kind of changed the problem around a little bit. So this is actually one piece. If I type sine of 52.25 degrees into the calculator, I would get a number to come up on the calculator. So although we don't know what this number is by just looking at it in this current form, I do have to recognize that sine of 52.25 degrees is just opposite divided by hypotenuse from a right triangle that has a 52.25 degree angle in it. And so I'm going to have to undo this multiplication by dividing the 40 that's on that right-hand side by that entire component, by that entire sine of 52.25 degrees. At this point, you can break out the calculator, double check, make sure that it's in degree mode. And if you type in 40 divided by sine of 52.25 degrees, what you're going to end up with is you're going to end up with 50.6 feet. So I rounded that to the nearest tenth of a foot. You have to kind of pay attention to what the problem specifies. This one really didn't specify anything in terms of rounding. So I just chose to round that to the nearest tenth. But just pay attention to what your professor, what your teacher, what the problem that you're working on asks you to do for rounding. And now I need to move on to part B. So part B says, what is the distance between the bottom of the tent and the stake? So that is on this triangle labeled as D. What I'm going to do is I'm going to get rid of this highlighting that we used here in part A. I'm going to leave the 52.25 degrees highlighted. I'm still going to work with that angle. But now what I'm going to do is I'm going to try to figure out how the side that we know and the side that we want to know, and in part B, it's side D, the distance between the bottom of the tent and the stake, how those are related to this 52.25 degree angle. So R is the hypotenuse, meaning we're not going to use the H at all within part B. What we have is we have 40 being the opposite side still, right? This is still on the opposite side of the triangle from the angle that we're looking at. And now side D is along that angle. It's adjacent and it's definitely not the hypotenuse. So we have O and A. So if you look what I did here, I don't have any sine, cosine, or tangent being used. So I'm actually kind of explaining the second portion of this first. So if I have the opposite leg and I have the adjacent leg as what I know and what I want to know for part B, I need to find the syllable from SOHCAHTOA that involves the O and the A, and that's the final syllable that tells us we're going to use the tangent function. And tangent of the angle that we were looking at equals the opposite leg, which measures 40 feet, divided by the adjacent leg. So I have opposite divided by adjacent, 40 divided by D. If I want to solve this, I have a very similar sequence to what we did over here. I'm going to have to multiply by D to get D out of the denominator. And then I'm going to have to divide by tangent of 52.25 degrees. Type that into the calculator, you're going to get your answer. You'll notice I actually did this a different way. So I'm guessing what you're probably more comfortable with because you've been using this for a few years already. You use it more often than you use sine, cosine, and tangent. It's a little easier to manage with. I've used the Pythagorean Theorem. In part A, we determined that this hypotenuse measured 50.6 feet. So what I did is I did this leg squared plus the leg that we wanted to know squared equals the hypotenuse squared. Well, if I want to solve this for D, I'm going to have to subtract the 40 squared from 50.6 squared. And then I'm going to have to take a square root to undo that exponent. So I just typed this straight into the calculator, square root of what you see right here, 50.6 squared minus 40 squared. I got 31. It was actually 30.98, I believe, when I typed it into the calculator. So I just rounded that to the nearest tenth, and that became a 31.0 feet. Which of these methods is preferred? Well, it kind of depends. They both get you to the right spot. The only issue with what I did right here within the Pythagorean theorem, this answer, 50.6, is rounded off, right? This calculation was not exactly 50.6. So when I do more math with a rounded off value, I do lose a little bit of accuracy within that final result. When I type this into the calculator, What I ended up with was 30.97. So this being 30.98 and this being 30.97, how different are those answers? Obviously not much, but you do lose a tiny little bit of accuracy when you do more math with a rounded off value. So if your teacher's asking you to find it to a certain degree of accuracy, you've got a little bit of flexibility to try to decide which is going to be the acceptable method to use. But both of them are going to get you to the right answer, just under 31 feet. 30.98 was the Pythagorean Theorem method, and 30.97 was the sine, cosine, tangent method. In the final video that we're going to do in this little sequence, we're going to look at a story problem where it's going to be on us to not only take the information from the problem, but build the appropriate picture and then solve it from there.